Okay, so I am picking up with, I skipped a couple of slides. If you printed the PowerPoints that are that are connected, um, I skipped a couple because it's a demonstration that you can do through the Launchpad Psych Investigator, and so I didn't want to repeat it for you guys. But the idea is we have limited intuition and common sense, and that's why it's really important for us to treat psychology as a science. When we try and use our logic to explain something that we've observed, a lot of times our logic falls short, and it's not because we're dumb, and it's not because we couldn't explain it if we put more effort in. It's because in most circumstances, our tendency is to come up with a solution that makes sense and then move on and not think about it too hard. So if you do the Psych Investigator that talks about common sense and intuition, you'll see the demonstration that I normally do in my in-person classes. Let me use some other examples that might help you to understand why it's really important to treat psychology as a science. Okay, here we have a nice phrase, absence makes the heart grow fonder. That makes sense, right? Sounds true. How about this one? Does this sound true? Seek and ye shall find. If if you actively look for things and are active and curious, that's how you will find the things that you need, right? The pen is mightier than the sword, right? We've heard all these phrases. These are sort of truisms. I don't know if that's the correct word for it, but we'll call it that. But what about this? Out of sight, out of mind. It's kind of true also, right? You've heard of your friend, or maybe it was you who had a long distance relationship and everybody told the two people it's not going to work. Long distance relationships never work because, basically what we're telling people is out of sight, out of mind, right? What about this absence makes the heart grow fonder? How can both be true? Curiosity killed the cat is sort of the opposite of saying seek and ye shall find, right? Seek and ye shall find. If you're curious and you're active, you'll find what you need. Wait a minute. Too active, too curious, bad things can happen. Both of those are kind of true, right? Actions speak louder than words. Wait a minute, I thought pen is mightier than the sword. The thing about the way that we think naturally, when we're not necessarily trying to be scientific, but we're just kind of going through life like we do 99% of the time. I'm a scientist. 99% of the time, I think incorrectly. I just recently did it. I won't bore you with it. Okay, I'll bore you with the story. My daughter was buying a package deal to fly to Ireland with her school. She's in college. She's at UW. And her school trip, they're going for 3 weeks for a business program, yada yada. She was told, if you can find a package deal that's less than $1,500 for your airfare, grab it, do it. So she did. She found one that was like just under $1,000. She's like, oh, so she grabs it. So then I see what she's booked, and I said, you realize you have a 24-hour layover in San Francisco. Why are you flying the day before to San Francisco? That's pretty crazy. But it's summertime, so I'm like, hey, why don't we take a family trip down there, and then you don't have to take the air trip, and we'll drop you off at the airport. That'll be fun. We'll take a trip to San Francisco. That'll be fun. So we all were thinking about doing that until it's getting close for her departure time, and she's starting to get kind of anxious about the fact that she's going to be away from her job for 3 weeks just for the school trip, and then add a week for us to drive her down to San Francisco. That was starting to make her panic. She's worried that she won't have time to pack and all her stuff. She started getting really nervous about it. So I could tell she's getting really nervous. So I said, you know what? Why don't I fly down with you, and then we'll spend one night together in San Francisco. So I found out that for me to fly down to San Francisco and back, that would be $300. And then I started thinking, I don't want to fly down to San Francisco for one night. That's really stupid. I don't want to do this. So I said, if you can find an airplane ticket that'll take you one way to San Francisco on the day that your other ticket is taking you to Ireland for less than $300, buy it. I will pay for it, so I don't have to make this stupid one day turnaround. So she finds a ticket one way to San Francisco for $200. Now, all of this took months of thinking and hemming and hawing and stuff like that, and for $200, she was able to change, to get a different flight for the first leg and make the whole trip more tolerable. But what had prevented us from thinking of it in the first place is a thinking error. Our logic is limited. We were sitting here thinking she had bought a package. Okay, if you aren't going to use the first leg of the package, fine, but you need to do something else. You don't fly to get to San Francisco because you already paid for your flying to San Francisco. You got to get to San Francisco another way, which is very illogical, right? Why do you have to go another way? By spending $200, she still was $300 under what her teacher had said. If you can get it for that price, you are way ahead of the game. She got it for still $300 under that. Our logic is limited. The examples that I've got on the screen right now are examples of what we call the hindsight bias. Now, as I'm telling you this story about the airplane tickets, now that we solved it and she was able to get a one-way ticket for $200, we're like, why didn't we think about this 3 months ago? Why did it take us until we were all freaked out about the trip and this and that to come up with the idea of buying a different ticket? Now, in hindsight, it makes perfect sense. But in advance, none of the four of us could think, just buy a separate ticket independent of the package. That's the trap we get in. We have difficulty sort of breaking that hindsight bias. Now that you know how it worked out, you think you should have been able to predict that outcome. So now that we know how well it worked out buying a new ticket for the first leg of the journey, we think we should have been able to figure that out earlier. Now that you've seen the statements on the screen, absence makes the heart grow fonder, well, that makes sense. Oh, wait a second, so does out of sight, out of mind. Now that we've seen how it works out, now we're confused and started to think, oh, wait a second, maybe it's circumstances, maybe it's the people involved, maybe there are other factors that determine whether absence makes the heart grow fonder or out of sight, out of mind. It isn't until you start to take the big picture into account all at one time and avoid that hindsight bias tendency to want to explain things that have already happened instead of trying to predict things that are yet to happen. In science, we want to predict things that are going to happen, and then we try and, I don't know if you heard that, but that was a motorcycle driving past the front of my house. Doing like 70. Anyway. In science, we try to predict what's going to happen, and then we collect data to see whether that's what actually ends up happening. In our normal logic, we see what has happened and then try and come up with explanations for why. And that's faulty reasoning because a lot of times we only focus on the parts that we choose to focus on, and we don't focus on the big picture. Another limit to our ability to make good judgments naturally is that we tend to be overconfident. We think we already know. I've got a link here. Oh, here first I got a cartoon. I know the last 5 scratch-off tickets didn't win, but which means this one has to be a winner. This is that kind of overconfidence that causes us to gamble, that causes us to do stupid things because we think we know how it's going to work out, and we haven't collected data or anything. We just think, okay, it has to be. It has to be. It's the kind of logic that made my mentor in graduate school, who was the stats expert in the department, come to the brilliant conclusion that because he already had 2 sons, the probability that his third child would also be a son was really astronomically small. He's like, there's no way. I did the math. There's no way the third one could possibly be a boy also, so I'm going for it. So, of course, the third one was a boy. He was overconfident because he was not using correct logic. The baby that he makes has no idea what's already there. The baby is 50-50 every time. So he was overconfident because he figured his stats were going to override the truth, which is it's a 50-50 chance. Now, if you want to play a little overconfidence game, you can go to the estimation quiz. I took it, and the estimation quiz asks you basically some trivia questions. And I knew what it was. I know what the game is. Don't be overconfident. So I thought I knew basically the answer to each of the questions, and I made broad ranges to really try and ensure that my answer would be in the correct range. And I still only got 2 of the questions right. It's really shocking how overconfident we are about things that we really shouldn't think we know the answers, because they're trivia questions that you probably don't know the answers to. And you know what's really interesting? The two that I got right were the two that I was least confident on, and so I made an extra specially broad range. But you can play that if you open up the regular PowerPoints and watch them in screen view. You can click on that hyperlink, and then you'll be able to go take that estimation quiz. All right, and then we have the tendency in our natural thinking to see order in things that are truly random. Our brains want things to be orderly, and so we see order even though there is no order. Which hand are you more likely to be dealt? The one on the left, Jack, Queen, Ace, King, 10, all our hearts, or the one on the right? 9, 3, 5, 8, 6, got a spade, we got a diamond, we got two clubs, we got a heart. Which are you more likely to be dealt? Well, the truth is you have an equal probability of either of these hands. But for a lot of us, when we see these two hands, the one on the left is meaningful, royal flush. The one on the left, we interpret it as junk. So we're like, I don't know, just random cards. And so we kind of forget that the question was, which hand are you more likely to be dealt? Because the one on the left has been labeled meaningful, we see order in it when really it's a random event to be dealt those cards. The one on the right, because we've deemed those cards in that combination to be meaningless, we think that it has a higher probability of occurring. But of course, what the question is asking is, what's the probability of you being dealt a 9 of spades, a 3 of diamonds, a 5 of clubs, an 8 of clubs, and a 6 of hearts? Well, the probability of getting that arrangement of cards is the exact same probability as getting the royal flush that you see on the left. We tend to perceive order when there is none. Given large numbers of random outcomes, some stuff is going to look orderly. I was sent an email with this picture on it, and it had instructions for how to fold the $20 bill so that you could get a depiction of the Pentagon burning after 9/11 and the World Trade Towers burning after 9/11. And it had a bunch of pontificating, but then at the end it says, what are the odds that a simple geometric folding of the $20 bill would accidentally contain a representation of both terror attacks? Well, probably pretty high, because if you fold it the right way, you do get a depiction of both terror attacks. And what's actually kind of interesting about this fold is that you see the Pentagon on one side, and you don't have to change the fold, you just turn it over, and then you see the Twin Towers on the other side. Now, you got to admit, independent of context, those pictures don't really, that bill does not really look like the Pentagon burning or the Twin Towers burning. It's in context that it makes it look like that. What's the probability that your brain would see something meaningful in something that's not meaningful? Pretty good. Here we have what appears to be a crane hanging the moon. And obviously somebody thought it was cool enough to take a picture of it and post it on the internet so I could find it. These things, this happened probably for several days running, frankly. And if you were standing from the right position, probably stayed even longer. Given large numbers of random outcomes, a few things are going to look orderly. Here we have brothers from another mother, right? Actually, that fur pattern is a really common fur pattern. A lot of animals have that fur pattern. It happens so often, but when you see two animals next to each other who are of different species having the same fur pattern, you start to think, wow, that's more than coincidental. No, it's called nature. It's random. This stuff happens, right? Our brains want things to be meaningful, and that limits our ability to think scientifically, because if we're busy thinking that there's magic behind the fact that the cat and the rabbit have the same pattern of fur, or there's some kind of conspiracy causing the new $20 bill to contain depictions of the terror attacks, you're not thinking very scientifically. You're looking for associations that aren't meaningful. Scientists need to not think like that. All right. Okay, now again, if you run the PowerPoints in screen view, like you're watching a PowerPoint show, and just flick through to this one, it contains Phoebe trying to cleanse Ross's aura. And I'm going to use aura cleansing as an example, so that's why I have that little video. It's very brief, 42 seconds, but you can't hear the sound if I push the button right now, so you have to watch it on the PowerPoints. So now let's take the concept. Can some people see auras? Okay. So how can we test this question? Can some people see auras? Now, if you're not familiar with the concept of an aura, there are people who believe that your body gives off a halo that can be detected by people who are sensitive to it, and that really probably all of us should be able to see auras, but only some of us tune into it and really pay attention. That's the concept. So James Randi, who used to be a magician and now has just gone full-time into being a skeptic and testing some of these paranormal claims, claiming to be able to see people's aura is a paranormal claim. So he developed a testable prediction, which is what you do in science. He came up with the idea that should you have to be able to see the body in order to see the aura? We should be able to put your body behind an object, and a person who can see auras, if there's, if it's a narrow object obscuring your body, a person who can see auras should still be able to see the aura that's hovering around you. The thing is, in the tests that he performed, not a single person was able to detect auras or whether there was a body behind the object at above chance levels. That's how you test claims. You set up a prediction, you think of a way to test that prediction, and then you see whether the prediction stands up. So let's go ahead and stop here, and we'll pick up in the next section and talk about how we go about science and how we think scientifically.